Okay, this time we're going to do the same simulation. We are just not going to do it with 50 cards. We're going to set up a computer to do a randomization test for a difference in proportions. And you can see over here, because of the way I populated it, I've pre-populated it with our data. In other words, 10 out of the 34 with seeds yawned, and 4 people out of the 16 that did not get a seed yawned. So these are my two groups, and notice that the difference in those two proportions is the same difference that we got when we were doing the card simulation. So the computer is now going to do another dealing of the 50 cards. And the first simulation got the exact same thing that the Mythbusters people got, 4.4%. And there's the dot, 4.4%. The next simulation is another 4.4%. Interesting. The next simulation actually got a negative, which is interesting. So they actually got that the non-seeded group yawned more than the seeded group. And so we keep doing this for a while, and we start to see how these pile up. So if there's really nothing going on, this is the differences. These are the differences we would expect. And now we can do like 10 more at a time, 100 more at a time. Or if we really want to get some definitive distribution shape and size, we can do thousands. So let me get it up to over 10,000. Seems like that's a nice round number. So 10,364 simulations of that same card simulation. And this is the distribution. And look where 4.4% falls. 4.4% is this pile right here. In fact, if we look at our distribution, 4.4% is the most common difference that you can get when you do a simulation. Now, if we click on right tail, what's interesting is we can ask the computer to tell us what percent of all the simulations ended up at 0.044 or higher. So it's going to shade in red the simulated proportion of times that we got a difference of 4.4% or even higher. This is essentially a p-value. This is a randomization test version of a p-value. This is the probability of getting a difference that we got, or even more extreme if the null is true. So look at this. There's a 51% chance of getting results this far or farther from the mean if the mean really is zero, if there's really no difference. This is basically saying the p-value is 51%, clearly way higher than an alpha level of 0.05. So therefore, we fail to reject the null hypothesis, and we have no convincing evidence that there's actually an effect from seeding people into yawning.